Write a polynomial with integer coefficients using these given zeros. All right, I'm going to approach this kind of like in a weird step-by-step basis. Thing number one, I'm given two roots. That doesn't mean anything. I actually have three, and you might be thinking, no, there's two there. There's a little thing called the conjugate rule that says if you have something in this form as a root, you must also have something in this form as a root. And you might be thinking, well, we don't have anything that looks like a plus bi. Yes, we do. That's a plus bi because it's a complex number that can be written out as 0 plus 2i, which means 0 minus 2i also has to be an answer. So I have to throw negative 2i in there. Okay, so that's thing number one that you have to be careful of. The problem is kind of incomplete and you have to fill in the blanks yourself. Those are my three roots. Now, another thing that I want to look at is reminding ourselves what zero product property says. If I have something that looks like this, and I'm just picking random numbers, if I have something that looks like that, I know that my answers are going to be x. Why did I pick 0? Let's make it a 10. X equals 5 and x also equals negative 10. So if I get the parentheses, then I know the roots. Well, now I have the roots, so I should be able to do this, throw opposite symbols in front of these and throw them in the parentheses to get a similar idea. So what I'm going to do is I'm going to write out x minus 4/5, x minus 2i, and x plus 2i. Now what I have to do is I have to simplify this out. So I'm going to use my eyes over here, knowing very well that things are probably going to go away, things will disappear, but I'm going to multiply this out. So I haven't touched x minus 4/5 yet. Not yet. I will. But if I FOIL this out, wonderful things are going to happen. X times x is x squared. X times 2i is 2ix. Negative 2 times x is negative 2ix. How about that? Negative 2i plus 2i, or times positive 2i rather, is going to be negative 4i squared. Now, before you're like, oh, this is a nightmare. No, it's not. These guys go away. And what's also nicer is I squared. Remember, I squared is the same as negative 1. So negative 4i squared is the same as positive 4 because it's negative 4 times negative 1. So let me write this out as x equals 4, not x equals, x minus 4/5 and x squared plus 4. Now let's factor, that's supposed to be a parentheses. Let's factor this out. X times x squared is x cubed. X times 4 is 4x. Negative 4/5 x is negative 4/5 x squared is negative 4/5 x squared. And negative 4/5 times 4 is negative 16/5. Now, before I call it a day, remember, this is all equal to 0. So this is all equal to 0. Before I call it a day, I'm supposed to have integer coefficients. So what I'm allowed to do is I'm allowed to multiply both sides by 5. Why am I doing that? To make these fractions no longer fractions. So by doing that, I now have a polynomial where I can have 5x cubed. Let's put it in order. 5 times negative 4/5 is going to be negative 4x squared. Okay, I'm doing this one. Plus 20x minus 16. That is a polynomial that when set equal to 0 gives me zeros of 4/5 and 2i. And oh yeah, by the way, negative 2i.